Hello, we are now looking at the last piece of section 2.1. So this is about finding the domain of a function. And if you recall, when we introduced the definition of the function, we mentioned that the domain are the values of the input, the values that the input takes. So for any function, the domain can be stated in the problem, or it could be just if no domain is stated, then it means the domain is going to be whatever the function domain is in general. So for example, if you look at the graph of the function f of x is equal to x square, the graph looks like, so f of x is equal to x square, everybody knows, is a parabola, right? So its graph is going to look like something like this, which is telling us that the domain is all real numbers, because all the values from negative x infinity to infinity, that is what the graph will take on. So all these can be the input of this function, because if you think of any real number on the real line and you plug in this function over here, you will get a real number. So there is nothing, no real number which will give us an undefined value. So it means the domain of this function f of x is equal to x squared is the all real number. But if in a problem we restrict the domain, like in this case when we have f of x is equal to x squared, but we restrict the x like this, that 0 is less than or equal to x is less than or equal to 5, it could be any value, then we are taking a restricted domain. It means we are not taking all real numbers, we are going to be in this interval. So if the domain is not given like this, then we will assume that the domain of the function is the set of all real numbers for which the function is defined as a real number. For example, if you have f of x is equal to 1 over x, now we know that any value of x will give us a real number if we plug in here. But 0 is the only real number which will not work. So which means the domain of 1 over x is negative infinity to 0 union 0 to infinity. Okay? So if we are not given a restricted domain, then in general that is going to be the domain of the function 1 over x. Okay, so how do we now find out the domain of different functions? So we have to, at this moment, there will be one more thing coming later in the course, but at this moment you have to remember two conditions. One is that we cannot have a 0 in the denominator. The second is that we cannot have negative values under a square root or an even root. So what do I mean by even root? I have mentioned this before, I believe. So this is a square root. Sometimes people put 2 here, but it is not needed. So if you have square root, or if you have a 4 here, or if you have anything in here, and there is a 6 here, or 8 or 10 and so on. So if you have even digits or even numbers over here, which means this is an even root, then we have to be careful that we cannot have negative numbers inside the square root. So what do we do? Okay, so when you have to be you have to be kind of alert or cautious when you are finding the domain. You have to know what type of function you are looking at. Okay, so in this case we will be working with 3 kinds of functions. One is polynomial function, another one could be the rational function, and the third type is the radical function. And then there can be combinations of those. If you have a polynomial like this first example here, this is a polynomial. This is a polynomial. So when you have a polynomial, you don't have to do anything. You just say that the domain is equal to negative infinity to infinity. Okay, or we can say domain and then we don't want to put the equal to sign. We can just say, put a colon, that this is the domain, negative infinity to infinity. So polynomials, they are nice. They have no holes, no discontinuities. We call them continuous functions. You will learn this or hear this in Calc 1, what are continuous functions, but you can, I believe you can know right now, or you know when there are no breaks. Okay, so in polynomials we don't see any breaks. Looking at this side, right side, number 2, f of x is 1 over x minus 4. So you notice here this is a rational function. So this is a rational function. So for a rational function, we have to be looking in the denominator. We don't worry about the numerator. No worries about numerator. But denominator cannot be 0. Yeah. So what do we do then? We take the denominator and we set it equal to 0, and we try to see what are the numbers which are making the denominator 0. And then we throw them away from the domain. Now in this case, we don't have to do all that work because we have only one factor and we can see x cannot be 4. So you can see that x is not equal to 4. Okay. So, but this is not the domain. You have to give the domain in terms of an interval. So therefore the domain is, so you can just write DOM colon. So it will be negative infinity to 4 union 4 to infinity. I hope everyone knows this is how we write in the interval notation when we want to throw away one value. Which value is thrown away? The 4. Okay, going to the next number. So this is number 3. H of x is equal to x squared minus 4 divided by 3x minus 6. Now we don't care what the numerator is as long as it is a polynomial, because polynomial is nice. It will, in the domain of polynomial is all real numbers. But if there is a denominator, we have to worry about it. Okay, so we have to make sure what that 3x minus 6 is not equal to 0. So sometimes I suggest that you write it like this. You take your 3x minus 6 and you say set it equal to 0 and then find what the x value is. Okay, so we get 3x is equal to 6, divide by 3, so we get x is equal to 2. So it means x is not equal to 2. Domain, in the domain, so the domain will be negative infinity to 2 union 2 to infinity. Now if you want to write it like this, because we know that 3x minus 6, we don't want it to be 0, so you can say this, and so this means 3x is not equal to 6 or x is not equal to 2. And then from there you can now say the domain. Okay, over to the right, number 4. So what another thing that you can do actually in number 3, let's go back to number 3. And another thing that you could do is factor everything. Factor basically the denominator. We don't care about the numerator. So you could see that we get x square minus 4 over 3 factor out, and inside I'm getting x minus 2. So now by looking at it, you don't have to do this work. By looking at it, you can see x is not equal to 2. And then you can write your domain. So we will apply the same strategy in number 4. So in the top we have x to the 4, which is a polynomial. So we don't care about that. But at the bottom we factor. So when I factor, I'm getting x plus 6 and x minus 5. Okay. So what does that mean? That x is not equal to negative 6 and x is not equal to 5. So if you want, you can write it. X is not equal to negative 6 and x is not equal to 5. Okay. So how do I write the domain now? So the domain will be, if you cannot do it directly, you can always draw a number line. So I can draw, I don't have space here, I will draw it on this page over here. So you draw the number line. So negative 6 will be on the left and 5 will be on the right of negative 6. So we have to throw these away. So you can make holes, circles, holes, don't fill them. So because these are holes, they are going to be thrown away. So now you can read from negative infinity to, so you see from negative infinity until here. So we omit that, which means we use the parentheses. And then from here to 5, and then again we have to throw 5 away, and then from 5 on to infinity. So the domain will be negative infinity to negative 6 union negative 6 to 5 union 5 to infinity. So that will be the domain. So now we look at the square root or radical function. Excuse me. So whenever you have a square root or a fourth root or a sixth root, usually you will see, normally you will see square root, but just in case. Then what you do, because we cannot have a negative number, so we say that 7 minus 3x must be greater than or equal to 0. And solve this inequality. So the better way to do this one is, instead of subtracting 7, I will add 3x to both sides. So this can give us 7 is greater than or equal to 3x. Now we divide by 3, so we get 7 is greater than or equal, 7 over 3 is greater than or equal to x, or x is less than or equal to 7 over 3. Therefore, from here we get domain is equal to negative infinity to 7 over 3, where 7 over 3 is included because of the equality sign. So this is how we can get. So the main key, the big key here or big point here is to remember this step. In this one, we take the denominator and set it equal to 0 and find, and then throw away the 0. In the case of a radical or square root, we have to remember this. We take the quantity inside the square root and set it greater than or equal to 0 and solve. And that is what is going to be your domain. Now in the right hand side, h of x, example number part 6. So h of x is equal to cube root of 1 minus 4x square. Now again, in this case, we don't care what is inside the square and radical. We know that this is a cube root, which is not an even root. Okay, notice here, this is not an even root. If it's not an even root, then the domain is, so in this case, the domain is equal to all real numbers. So we write it. Remember, writing all real number is not enough. You must give the answer in interval notation.